So I told you in the last video that I would do another video on nomenclature of branched substituents. And that's what we're going to do here in this video. But first let's go back and have a look at branched hydrocarbons. And what do I mean by branched? Well, you see that we have these branching points, or places where we deviate from the linear carbon chain. And you saw some examples. We saw isobutane, isopentane, and neopentane. And remember that these are constitutional isomers of the normal alkanes, or of normal butane and normal pentane. These names are accepted by IUPAC, even though these are common names rather than systematic names. In other words, unless you memorize these terms, isobutane, isopentane, neopentane, you can't really figure out what the structure is if you knew the rules for nomenclature, right? So these are the common names, but these compounds also do have systematic names. Let's go ahead and figure out what their systematic names are. So if we look at our first example, isobutane, remember that we have to find the longest continuous chain of carbons, and here it is right here. It's a chain of 3 carbons. I have 3 carbons, I have 1 methyl group. The methyl's on the second carbon, so that name would be 2-methylpropane. Right? So 2-methylpropane is the systematic name for isobutane. Either one of those names is fine. Our second example, isopentane, has a 4-carbon continuous chain with a 1-carbon branch. My 1-carbon branch is at the 2 position. Since I have a 4-carbon chain, that would make this a butane. It is a methylbutane, and the methyl group is at the 2 position, so it's 2-methylbutane. My next example, if I look at neopentane, I have my longest continuous chain of carbons is 3 carbons long, and I can either count in the horizontal direction or I can count vertically. Either way, it doesn't matter. I'll still come up with the same name in this particular example. So I have a 3-carbon chain, so that would be a propane. I have 2 methyl groups. They're both at the same place. They're at the 2 position. So this would be 2,2-dimethylpropane. So I want to go ahead and look at branched substituents. In the last video, we only looked at unbranched substituents and how to name those, but you can also see branching in the substituents. And how do you handle that? Well, let's just look at a few examples. So in this first example here, in all of these examples, I'm going to draw the bond that attaches my substituent to the parent in red, just for clarity. Makes it a little easier for you to interpret, I think. Now what you see with this example here is that we have 5 carbons in a ring. That would make this part of the molecule cyclopentane, and we have a 3-carbon attachment, or a 3-carbon substituent. You can also see that this 3-carbon attachment, 1, 2, 3, there's my 3 carbons. Right? This 3-carbon attachment is not branched. So here's my 3-carbon attachment. It is unbranched. So this one is pretty straightforward. I'm sure that you could handle this. The name for this molecule would just be propyl cyclopentane. Propyl cyclopentane. Pretty straightforward, I think. Let me go ahead and just move this. Let's go ahead and have a look at another example. Now, I think that you can see that this molecule is very similar to the first one that I showed you. I have a 5-carbon ring, so that's a cyclopentane, and that is attached to a 3-carbon substituent. But this 3-carbon substituent is a little bit different from the first one. Here we have 1, 2, 3 carbons, but you can see that now we're attached to the cyclopentane ring at carbon number 2. The way that I'm going to name this is, for this 3-carbon group, I have a special name. So the name for this substituent is isopropyl. Obviously that's an isomer of the propyl group, and I am attached to a cyclopentane. So there we go. Isopropyl cyclopentane is the name of this molecule. Let's go ahead and look at another example, and I think you could probably figure this out pretty quickly. I have a 6-membered ring, and attached to that 6-membered ring is a 4-carbon chain, right? So 6-membered ring tells me that this is a cyclohexane, right? And my 4-carbon attachment is a butyl group. So this would be butyl cyclohexane. And I should point out that in all of these examples, since we only have one substituent on the ring, I don't have to give it a number, because if there's only one, you assume that it's number 1, and that is implicit. You don't have to specifically say number 1. Well, how about this example right here? Again, I have a 6-membered ring, and attached to that 6-membered ring is a 4-carbon substituent. 1, 2, 3, 4. So there's my 4 carbons. Now this is also going to be a butyl cyclohexane, but now I have a branch in my substituent. I have a branch right there. So I'm going to have to give this a different name. And since this group, this substituent group right here, looks like isobutane, the name that I give to this substituent is isobutyl. Isobutyl. So this compound is isobutyl cyclohexane. Again, what do we have here? We have a 6-membered ring, so that's a cyclohexyl, and we have a 4-carbon substituent attached to that 6-membered ring. 1, 2, 3, and 4. This time, my substituent is not branched, right? But it is attached at a different carbon, right? It's attached at carbon 2, not at carbon 1. So you're just going to have to memorize the name for this. The name that I give to this now, and I'll explain this to you, it's obviously going to be a butyl cyclohexane again, but this time it's going to be a sec-butyl cyclohexane. What is sec-butyl? Well, sec tells you that the butyl group is attached at the secondary carbon. And here's the last example that I want to look at. Again, we have a 6-membered ring, so it's a cyclohexane, and that is attached to a 4-carbon substituent. Let me go ahead and count those carbons for you, just to be clear. I have 1, 2, 3, 4 carbons. There they are. I have a 4-carbon substituent. We've seen 3 other cyclohexanes with 4-carbon substituents attached to them, and they all have different names. What do I call this one? Well, this one over here I called sec-butyl because it was attached at a secondary carbon. Turns out that this one I'm going to call tert-butyl because it's attached at a tertiary carbon. So let me go ahead and just write that name for you now. It's called tert-butyl cyclohexane. And these are substituent names that you're going to have to memorize. Isopropyl, isobutyl, sec-butyl, and tert-butyl. Now, before I move on, and just to avoid any confusion, I want to point out to you something that's really important, and that is that this carbon here, the way it is shown in this molecule, is not a secondary carbon, it's actually a tertiary carbon. because we have 3 other carbons attached to it. When we say sec-butyl, we're really referring to the secondary carbon of the butyl group, and that's where the attachment is. So it refers to that carbon in the parent molecule when it's not attached to another chain. By that same token, this carbon right here is not a tertiary carbon, it's actually a quaternary carbon, and by that I mean it has 4 other carbons attached to it. But if I look at isobutane, and that's really what is attached to this 6-membered ring, is an isobutane molecule, and it's attached at this position, and that is a tertiary carbon. So that's what I mean when I say tert-butyl. It's not that in this molecule, this is not a tertiary carbon, it is a quaternary carbon. So just to avoid any confusion on that point.